On problem 5, we've been given data, so we need to find the equation that we're trying to analyze. So I'll copy the data in and then get a graph. If you need a trend line, you need the separate points. And then add a chart element, trend line, more options. A cubic function is under polynomial of order, change that to 3, and display the equation on the chart. Now, since it's a cubic function, cubic and exponentials, you want to make sure that you have 5 decimal places. And on these two coefficients, I only have 2. So with the equation selected, I'm going to right-click, format the trend line label. Under the 3 bars, go to the number category up to 5. Okay, this will be the function for my model. Keep my graph here. So let me copy that and set up my function. I need to do some editing. That'll be easier up in this formula bar, easier to see it. So make it times. This will be my x value cubed times my x value squared. Oops, missed my x value. There it is. Plus times my x. Okay, and then my x value, I want to start at 0. Let me move my graph over a little bit. I want to just bring in some labels. Insert and shift to the right. Good. Okay, so this is my left endpoint. I have a right endpoint at 16. Copy that value down. And then looking at my graph, it's a little hard to tell. Like it definitely goes up and then it looks like it goes back down. So there might be a maximum in here. If I want to get a little bit better view, I'm going to click on the axis and then format the axis. Right now it goes from 0 up to 700. The smallest my data gets is around 400. So I'm going to go 375. And now I have a little bit better view that it does go up and then it comes back down. So I think there's going to be a relative max right in here. So relative max, I'm going to take a starting guess of 5. Apply my formula to that and then bring up the solver. Set this value to a maximum by changing this cell. 5.99. And then there's also a maximum at this endpoint, which would be at 16. Local minimum, it looks like it dips down. There's going to be a lowest regional point right here at about 10. Let me find a relative min. Start at 10. Bring up solver. Set this to a minimum by changing the corresponding x value. Oh, and I forgot to bring my formula down. Let's try that again. Take solver, set this cell to a minimum by changing that cell. It should work now. 9.88. And then there's another local minimum at this right endpoint, which is at 0. Absolute max and absolute min. So the smallest number out of all of these is my left endpoint number that happens at 0. And the biggest number out of all of these is my right endpoint, happens at 16. Looks like I got a little bit sloppy. I forgot to put a none in for answer B because there aren't any roots. The graph never crosses the x-axis. And then maximum is on the first question and minimum is on the second question.